Yeah, this is a world premiere of this robot.
Very, very rare. Fine.
Yeah.
Wow. Tabletop challenge? Wow.
Yeah.
Have fun.
All right. Yeah.
Got it. You got it. That's what you have to do.
Back in August, I gave a mini presentation on deep learning for reinforcement learning for robotics. And since then, I worked on my ROS-based robots and trying to get them to work with Gazebo and do some fancy simulation stuff for deep reinforcement learning. And then I got very frustrated with incompatibilities of ROS when you upgrade and with Gazebo not being very realistic. So I decided to kind of bring down the level a little bit. And I put together this robot. This is Deep Understanding Robotic Ant Durant, first name Kevin. And this base was from Dave Calkins from the SIG swap meet a couple years ago. So it's made its way back. I designed this robot specifically with deep learning in mind. If you look at the reinforcement learning lab in Berkeley or in the OpenAI.com group, their papers are all based on these simulations. Some of these simulations are brain dead simple. One of their more complex simulations is an ant going through a maze. Well, after reading a bunch of these papers, I go, I'm not sure that these stuff will work on a real robot. So instead of, if their stuff was demonstrated on the ant going through the maze, the idea is to have a real robotic ant doing the tabletop challenge. Now this is, a lot of their challenges that they do are not, are actually very simple operations, one move things. The thing about the tabletop challenges, it's a series of challenges, each getting building on each other, and a lot of neural net stuff doesn't handle that very well. Unlike the donkey car, which is based on and vision-based learning, this one tries to avoid all the vision. I'm a big fan of the donkey car. I'm building my own donkey car. Parts are in the way, and a couple other people are here too. But so I'll be doing the donkey car as well, but that's for the vision-based. This is for the non-vision-based. And for the non-vision-based stuff, a lot of that is kind of step-based. It does a move, and it gets all the sensors from that move and things like that. So briefly about the sensors. Each foot here, I added a foot sensor, so when it touches the ground, it knows it touches the ground. It's got a camera, but it really doesn't use it as a camera. It's more to detect fiducials. And it says where the center of the fiducial is and the size of the fiducial. It's supposed to have a pressure sensor, but that's not here. This is a work in progress, so don't expect a beautiful demo, okay? This got a pressure sensor there to check to see if it grabbed the cube. It's got a, now one of the things these simulations typically do is they assume that they know the exact location that they are in, let's say in the maze. How did they figure that out? They don't use SLAM. No, of course not. They just look up in the simulation and says, I'm at X and Y. But they often do things and assume, kind of compute based on this global knowledge, what velocities are and other things. So just to estimate it, because they're mostly used for rewards in these functions, I have a nice quality IMU from one of my ROS robots. And that's to compute some of the rewards. Now, what it does is it takes a step, it records a bunch of stuff, and then that data can be used to train a neural net off as training data for a neural net, so that I don't have robots learning how to fall off the table continuously by doing random movements. So with that being said, I'm going to try this thing up. It takes a couple. It's actually booting from a Raspberry Pi here, and it's supposed to auto boot. Let's see if it actually works, and kick this thing off. Now, first thing it does is it actually calibrates on the. It's kind of dark in here. We'll see what happens. It calibrates on the Aruco type fiducials here. Now, Originally, I tried to use QR codes using OpenCV, but those QR codes had to be within an inch of the camera and perfectly horizontal. It sucked. I wanted distance. And I was also frustrated that it took up a whole gig of this guy's memory. So I wrote my own Aruco code to do this, and it takes up a tiny fraction of the other Aruco code. It's in Python using some other libraries. Right now it's calibrating. It takes a second to go through all this and calibrate. So we'll see what happens. Hopefully everything will work. So it's going through and it's kind of dark in here, so it's taking a little bit longer to calibrate and to figure out what is the right lighting condition for this. So I'm hoping it's going to start moving any second now. Okay, it's actually calibrated now. So the first phase is just to get over to the other side. It's also got 3 different time of flight distance sensors in the front there. They're much better in my opinion than ping sensors if you only care about 1,000 millimeters or so. I ordered 3 distance sensors that were supposed to be 1,000 millimeters. I got 2 that were good for 100 millimeters and 1 which is good for 1,000, so be careful for what you order. So it already the distance sensor's already detected the end of the table, so it's doing its very conservative walking right now because it's using its foot sensors to figure out if it's close to the edge. Yes, sir.
Whose time of flight?
VL50,
50.
yeah, S, yeah, that one.
Yeah, the SDN, which is good to 200 millimeters.
There's 1,000, there's 100.
It's supposed to be good to 2 meters.
2
meters. It's only good to 1 meter at best.
Yeah.
No, that's my experience.
Or the 6180.
Yeah, this one is 800. It has been okay up to no, actually more like 500.
So that's 73L.
So okay, well I don't know why it stopped here. Let's see.
It's a demo.
It's a demo. So I don't know what it's doing right now. It's supposed to go all the way over to here. Okay.
It did.
Okay.
Got pushing me off that table.
Okay, now it thinks it reached the end of the table. It's going to move backwards now using the same type of approach. Since there is no vision on top or there's no forward-looking sensors, it's going to just do this kind of conservative backward walking in favor of making things work fast. Okay, well, I had it off the ground, so it thinks it reached the end. One of the problems is that it doesn't have a pressure sensor in its over there that it's supposed to have to know that it grabbed this thing. The other problem is this cube is almost as big as the grippers, and I don't have things tuned yet. So I am going to just kind of semi-cheat and let it just grab this thing. I hope. Please. It's moving forward very slowly here.
You find the big
It is.
Here it is. Come on, come on, come on, come on, come on, come on, come on. Okay, grabbed it. So now let's start searching around for the Aruco on the board here.
Wow.
Don't walk off the edge. It's going to walk off the edge, I think. So it's slow, but it's recording data on every step. It's recording all probably 20 or 30 sensor readings. For each step, and including, okay, it's really close to the edge here. All right. See, it would have avoided it, but then it would have just taken forever to get to this point. So let's hopefully get it close enough.
Need to get some glasses.
I need new glasses, don't worry. Okay, now it's calibrated for the cube over there when it's facing that direction. I don't know if it's going to see the Aruco when it goes the other direction. Let's see if it figures it out. If not, I'll just call it the end of the demo. It's
Would it
not.
just drop it once it's in the bottom?
We shall see. Okay, it's now doing the slow crawl towards the box. Very slow crawl towards
Nice.
towards the box.
How many motors in that thing?
There are there's 2 servos per leg. There's 6 legs plus 1 on the gripper. Okay, we're just gonna let it figure it out. Drop.
John?
Please, just drop it.
What processes you running on?
It's a Raspberry Pi 3. Oh, which reminds me. So while I'm waiting for this thing to screw up, one of the things I bought was this Intel Movidius chip. It's supposed to be a neural net on a chip that is designed to work with the Raspberry Pi, and I'm just starting to play with it now, so this will be interesting. Last chance. Come on, figure it out. So I'm going to use this for both the donkey car and this. Drop it. Drop it. Drop it. Drop it.
Please drop it. Does it get a treat if it does it right?
Well, it's supposed to get rewards. That's the whole idea, right? This is reinforcement learning, right?
Reward should be that.
Oh, I don't know. It's taking a bow. I'll just call that a day.
It's successfully learned that if it does nothing, you'll do it for it.
Well, it was the example of the tabletop challenge, which is kind of one of the hallmarks of this club. And in the summer, starting in June, we have meetings. Our entire meeting is for tabletop challenge robots.